Hi everybody, this is Suvarchala working as an associate professor. In this lecture, I would like to discuss the questions given in the question bank, tutorial question bank related to the first module of database management system. Each module consists of 3 categories of questions. Those are divided in part A, part B, part C. Part A questions are short answers. 1 or 2 sentences answers will be given. Supposed to be questions must be having 1 or 2 sentence answers. Part B consists of big answers, we will call it as. Some explanation is required. Some problems will be given to solve the problems. And part C consists of some analytical questions. Whatever we learn during this module, that is conceptual modeling and introduction to database management system and conceptual modeling, that we are going to have how to apply these things for any problematic situations. So first I'll explain what are the questions are there, and first I'll explain the part C first initially, because part C consists of some problems to be solved and applied the concepts which we learned in this module. 10 to 12 lectures were given on this module syllabus. Some of the questions, theoretical questions, can be taken from those lectures directly. And the questions which are related to or having some problems or any algorithm, etc., some analytical questions are there. Those questions are going to be addressed in this session. Part C consists of 10 questions. Each question is going to be categorized, and which Bloom's taxonomy, under which level that question comes, was given already. And also the course outcome, which course outcome is going to be achieved from this particular question. If any student answers, which course outcome is going to be achieved. These are specified in the question bank given to the students already. And some of the questions we'll discuss, solutions we'll discuss here. The first question, ER construction, ER modeling, because the C part consists of theoretical thought processing, some thinking or logical issues to be introduced to solve such type of questions. So that's why first we'll discuss part C. The first question of part C is construct an ER diagram, keeping track of the exploits of your favorite sports team, any sports you can take. You should store the matches played and the score in each match, the players in each match, and individual player statistics for each match. Summary of the statistics should be modeled as a derived attributes. That is how much total score and what is the score of individual. All those things are going to be derived attributes. So for this problem, first we need to identify what are the things are major things. ER diagram means first we need to identify entity sets, and also relationships. Entity sets and relationships. So anyway, related to any sports, it's a more generalized entity relationship diagram to be modeled actually. So what are the entity sets means? As we aware of that, entity, while drawing entity diagrams, we have to identify which of them are entity sets. You can consider some nouns, common nouns are there, those will come under the entity sets generally. And we will eliminate some of them depending upon the permanent storage is required or not actually. In this example, we have to store the data related to the matches. We have to store the data related to the matches. And also we have to store the data related to players. Related to players. So the players and matches. These two entity sets are connected with a relationship played. with the relationship played. So first, for drawing any ER diagram, we supposed to identify entity sets as well as the relationships among the entity sets and attributes related to each entity set. So each entity set will have some attributes related to that particular entity sets. For example, in this case, match, when the match was played, where it was played, and all those things will be there. Player related to player ID will be there, player name and number of matches played, etc. will be the information. But we need to store the score of the player had. How much score that particular player scored during a particular match must be considered. That means that is derived. What is derived attribute? Derived attribute means the attribute value which is going to be computed from the already existing attributes. We will call it as a derived attributes. Generally, at the time of discussing these attributes, derived attribute need not be stored permanently because derived means calculated, no? So at any time you can calculate them. But for simplicity purpose, querying answers frequently, such attribute values are required. We will store that attribute also. So derived attribute is represented by using a dashed line in ER diagram, which we discussed all in the ER diagram related lectures. 2 lectures we have done. So in that particular lecture, we explained in detail. So in summary, we have 2 entity sets, 1 relationship for this problem. So we identified match, player. Match is having various attributes, date, match ID, stadium at which it played, opponent who is opponent, own score and opponent score. It's a more generalized one. It's not a particular. If you want to use, you can cricket match or anything actually. And player played that particular match, who are the players played, their name, age, some additional attributes may be there, address and phone number, etc., etc. But more important thing is what is their contribution. Their contribution is identified based upon the score actually. So season score. This is a derived attribute. So this is the solution. 2 entity sets connected with a relationship set and the entity set season scored. Similarly, sometimes own score and opponent score also can be considered as a derived attribute here also. If the scores are going to be considered as a combination or a sum of the scores done by the respective team players actually. Or this is a more generalized small ER diagram for the given problem, more generalized. For example, if you are taking some particular player, we can modify our definition also. For example, the requirements are given properly, we should have drawn a better diagram also. For example, National Hockey League, one more example I am explaining. So many teams will be there. When the league matches are conducted, National Hockey League, many teams will be there. Each team will have name and a city, a coach and a captain and a set of players will be there. And each player belongs to only one team. Each player has name, position, that is their specific, depending upon their specific skill and a skill level and a set of injury records. And team captain is also a player, remember that. So some generalized, specialized player is considered as a team captain. Game is played between 2 teams, referred to as a team. Teams are going to be categorized as a host team and guest team. And the host team and guest team means they are going to have a match date and score, that is 4-2. That means 4 goals in one match, one team and 2 goals another team, like that. So it will be having 2 teams score will be represented, and for this we have to construct a ER diagram. This type of definition of the problem is a little bit explanatory. Problem itself is a little bit explanatory. Our requirements are given very explanatory manner. In such cases, you have to draw a diagram based upon the steps which we explained in the lecture actually. That means here what are the first entity sets? What are the attributes of each entity set? Then what are the relationships among these entity sets must be identifiable by us. For example, in this case, team is an entity set because NHL is having multiple teams. So team is having some characteristics, attributes, has name, city, etc. So that's why team is an entity sets with specified attributes. Player is also an entity set with specified attributes, as well as team captain is there, but a team captain is a subset of the team player. And game is played between, no, so game is played means it is going to be considered as a respective relationship actually. So among the teams only game is going to be played. So it is a unary relationship, I can say. One of the team is guest at one time, another team is host. So the team is related to itself with the game relationship. So one of the team is guest, another team is host. Now one match, host team may be a guest in some other match, remember that. So that's why game is a relationship. So these are the team, majorly player. These two are the entity sets. And we have injury records. Injury record is considered as a weak entity set because it doesn't consist of any specific definition of key definition. So that's why injury ID as well as description, what type of injury. This is connected with log. With each player is having a set of injuries, no? So record of injuries will be there. So with the log file, each player is connected with the injury log file, which is a weak entity set. Now game, as I told you, game is played between teams only. So game is a relationship. But what are the two entity sets? Team only. Between two teams means team is, one of them is guest, one of them host. So that's why it's a unary relationship. Game is a unary relationship where the team is an entity set, single entity set connected with itself. Each game is having, this relationship is having two attributes, the specified date on which that particular game was conducted, as well as the score. Now coming to the relationship between the team and player. Player belongs to a single team. So that's why multiple players belongs to a single team. Arrow mark is towards team. And one more is there. One of the players are going to be captain to a team. Captain is one of the relationships, you can say. So one of the player is connected as a captain to a team. So two relationships are there. This is 1-to-1. One player can be a captain to one team only. One team can have only one captain. So both side one relationship is there. And the connectivity is going to be considered as a 1-to-1. And attributes are there. This is a relationship if the statement of the problem is given a little bit explanatory manner. Our requirements are provided widely. And the question 2 of the part C seems to be a big question, but very simple logic is there. What is the question here? Let E1 and E2 be the two entity sets, in other words, in an ER diagram with a simple single valued attributes. R1 and R2 are relationship. That means E1 is one entity set, E2 is another entity set. These two are connected by using two relationships. What are the two relationships? R1, R2. Two relationships are there. Right? So what are these two relationships? R1 is a one-to-many. For example, this side one, this may be many. And R2 is a many-to-many. Many-to-many means this relationship. Then we need to find out how many minimum number of tables are required in a relational data model. That means the conversion of ER model into relation model is to be considered by us. So while converting an ER model into relational model, some set of rules we discussed in the previous lecture. So by converting ER model into relational model, one specific lecture was introduced. So in that lecture, elaboratively explained everything. Now in this example, considering two entity sets are there, both are strong entity sets. So that's why for each one entity set, one table will be there. So two entity sets means two tables are required for us. Two entity sets. That is evident. Another, coming to the relationships, one of the relationship is one-to-many. For one-to-many relationship, a new table need not be created. The primary key of one side entity set can be added as a foreign key to the other side entity sets, many side entity set. That is, referencing key can be specified. So, primary key, foreign key relationship will be established between these two. If any of the considered to be as a E1 and E2 are having the relationship one to many. So no table is required. Coming to the third one, R2 relation. It is a many to many. In case of many to many relationship, we cannot add primary key of one to other anyway. In such cases, what we have to consider? The many relationship must be considered to create a new table, which consists of minimum attributes as a primary keys of the both tables. In addition to that, if the relationship is having more attributes, those are added. But in our problem statement, R2 is a many to many relationship, but R2 doesn't have any attributes of their own. So that's why third table is for multiple many relationship. So one table for E1 entity set, another table for entity set E2, and another table is for many relationship R2, which is having two attributes minimum, primary keys of both entity sets. So how many minimum tables? 3 minimum tables are required for the above simple problem statement. And question 3, third question of part C. Analyze and find whether modifications made at conceptual level makes an application program written by user at view level to be modified in the database. Analyze your answer with an illustration. Answer is no. No means no need to rewrite our application programs. If you are doing any modification at conceptual level, that need not affect the application programs which are already written in the next higher level. Next higher level is view level. So what is the levels of abstraction? Physical level, conceptual level, and multiple view levels will be there. Multiple views will be there. While doing this process, what happens here? When we are doing here, the respective operations are going to be performed when data independence comes into the picture. Levels of abstraction we consider. Data independence means modification at one level doesn't reflect the or doesn't affect the whichever the things are available already in the next higher level need not be rewritten again. Based upon this this is an application of data independence. Based upon the data independence, the answer is no. So conceptual modifications need not, it will automatically get reflected. We discussed already these things. Why? Because from one level to other level, an interface will be there. So any modifications are made, the interface will take care of how to translate them. That's all. So the next higher level, no need to worry to be rewritten the applications again. Applications at view level need not be rewritten. That is, no modifications made at conceptual level need not make the application programs developed at view level already to be rewritten. Reason is data independence. That too logical data independence. I'll take an example. Many banking systems are there. For example, in a banking system, many application level programs are there. Withdraw, ATM, if you are going ATM or online transactions also, fund transfer, multiple applications are there. At the conceptual level in banking environment, they may be changing the schema of our accounts. They may be changing of schema of some other things related to banking environment, new branches added, new, respective data related to customers are going to be changed, structure is going to be changed. But it doesn't reflect our application. Every time they are not going to rewrite again all these applications, withdraw, deposit, and all those things. I'll give one more example, which all of us are having experience. For example, railway reservation system. All of us are having experience how to book a ticket. Are you thinking it was developed, let us assume that in 1980s or 19, at that time, whatever the rails and whatever the tracks are and the routes are available, those are going to be as it is. No new trains are added. No new routes are added. So that means keeping at the level of conceptual, logical level, new trains are added, new bogies are added to the trains. That means the structure of trains are changing, the routing of the train, routes of the trains, stops of the trains, etc. are changed. But whatever the applications are already developed, reservation, that is reserve, cancellation, payment, all these applications developed at view level, they did not change. No, they didn't change also. It is like that only we are using them actually. So that means the conceptual level, whatever the changes we are making, that need not be reflected at view level actually. Okay. So this is related to data independence concept. Next question in the C part. We can convert any weak entity set into strong entity set by simply adding appropriate attribute. Yes, we will call it as a discriminator, as well as identifying entity sets, which primary keys are added to our weak entity sets to convert into strong entity set, which we discussed already, and all of us are aware of that. Analyze why then do we have weak entity set? Why should we have? The main reason is we want to avoid the data duplication. If you are including directly in our strong entity set, data will be duplicated. Most of the redundancy will occur. To avoid this, because of duplication, multiple problems we would have to face. Our ultimate goal is in database management system, reduce the data redundancy as far as possible. That's why we are using normalization process also. So that's why to avoid this data duplication, as well as whatever the consequences are there, that is inconsistencies, errors, etc., caused by the duplicate error values, to avoid them, sometimes weak entities are required, which doesn't have self-existential primary key. Because of this, what happens? Duplicating key of the strong entity set can be caused. And weak entity sets reflect the logical structure of an entity being dependent on another entity, as statement itself given. Weak entities can be deleted automatically when their strong entity is going to be deleted, because it completely depends upon the strong entity. So I'll give an example. For example, when we are considering platform and train mapping, on the same platform, every time same train need not be there. During that period of time, time is also there. During the period of time, schedule, if the platform is vacant, train will be in that same platform in a particular station. So it is a weak entity actually. Each schedule on the platform, train, none of them are going to be having proper way. Depending upon the slot, depending upon the time available, reaching time, arrival and departure times, the platform is vacant, then it will be. That scheduling is going to be constituted as another task, but representation of this data will be an weak entity set actually. Weak entities can be deleted automatically. What is a strong entity? Train entity set, it is connected, as well as a platform number, it is connected ID based upon that the time actually. And weak entity sets are going to be generally stored physically with their strong entity sets. Because of that, existence of the weak entity sets are required, even though strong entity sets are available. Because their existence depends upon the strong entity set with which they are associated. Coming to the next question of part C only, fifth question. What are the responsibilities of database administrator? I need not tell much. More number of times we discussed this concept in the lecture as well as in the terms and terminology also. If we assume that a database administrator never interested in running his or her own queries, does the DBA still need to understand the query optimization? Why? Yes. Answer is yes. DBA still need to understand query optimization. Even though he or she is not using any of the database queries, they need to understand the optimization. Why? The reason. First, we'll discuss in brief what are the responsibilities of DBA. DBA will design logical and physical schemas and allow the modifications of these schemas and also give the permissions to external schemas for various users, provide security and authorization also provided by DBAs, and data availability, recovery from failures, how to recover. All these things are going to be decisions taken by the DBA. Basically, database tuning is the main responsibility of the DBA. So, what is meant by database tuning? Where the data was stored, how much memory was allocated, and how the performance is going to be considered related to performance. Database tuning means always DBA is responsible to effective processing of data from our database actually. So this database tuning in is a main responsibility. Tuning means our database must be effectively execute the queries given by the users, requested by the accessing and modification of the data must be very, very fast and effective, irrespective of the load of the users, irrespective of the availability of the memory, and so on and so forth. Such a way it has to be tuned by DBA. So that's why even though DBA is not using database to get some responses or for implementing their queries, is supposed to understand how to make their database as working as effective as clients are expecting. So that's why DBA needs to understand query optimization, even if she or he is not interested in running their own queries, because some of these responsibilities, that is database design, tuning, etc., are related to query optimization. These are the responsibilities supposed to be fulfilled by DBA. So that's why they must understand the optimization process effectively. Then only tuning can be done proper way so that the queries are going to be get executed very effectively. The next question is describe the structure of the database management system. This is all of us aware of that. A diagram also was given, explained multiple times in various lectures. And the question is, if your operating system is upgraded to support some new functions on OS files, example, the ability to force some sequence of bytes to disk, etc., which layers of the database would you have to be rewrite to take advantage of this? So operating system means internal. So internal functionality was enhanced. To get implement or to get apply these enhanced functions to storage of our majorly database storage, we need to do some modifications if necessary at physical level. Because physical level only how internal storage is going to be carried out will be considered. So that's why, if necessary, depending upon the enhancement of the functionality of the operating system, that too. If really it gives us more effectiveness in our database implementation, then some are need to be modified at physical level. But remember, whatever modifications we are making physical level may not reflect our conceptual level, that is data independence. So that's why you need not worry about the other levels. Only with physical level is required. Definitely it is related to file. Remember that not all functionality is related to file storage enhancements. The next question is why relational model become more popular comparing with other record-based models. I explained this during the lecture, Introduction to Data Models. Again, I'll tell. Basically, we will consider two reasons: research-based reasons and commercial implementation related reasons. First, I'll discuss about the research-based reasons. Research-based reasons means our relational model is basically defined as well as explained based on the mathematical set theory concepts. This is the set theory concepts are basis for our relational model actually. Set theory concepts are basis, a relation defined as a set, and the relationships among the attributes defined as a functional mapping, and so on and so forth. That means the entire relational data model is defined based upon our set theory. That is, what is the basis? Mathematical basis is the set theory. Remember that any concept which is mathematically proven or based upon mathematics, then automatically the respective concept failure rate is very, very, very low. You observe any engineering related concepts, mechanical engineering or automobile engineering, any engineering related concepts. When we are using these engineering concepts, the respective things are going to be considered based upon the process. So that's why when we are using the respective components, the basis is set theory. So that's why as a mathematical model was developed by mathematician Card, and it is lots of research is going on. Still research is continued. So that's why in such cases, the research based reasons are these things. Still research is going on various branches of relational database management system. So that's why it is becoming more popular. So why relational data model become more popular comparing with other record based models is the first reason is research based reasons, because it is based upon the mathematical set theory, failure rate is less, and the research is going on still on relational database systems based upon these mathematical related concepts. Coming to the second reason, commercial implementation. Commercial implementation means it's based upon record based. Record based means we have been using files from our beginning of the introduction of computers for data processing. So all record based models are going to be very, very easy to understand by us as well as implement. Among them, this relational model is almost equivalent to a file system only. It is having the relationships among them, but it is having the file system means each relation can be viewed as a file. Each table can be viewed as a file. Based upon this file system, we are able to understand properly this relational model comparing with our network model as well as hierarchical model. So that's why implementation becomes very easy. The people who are working with these relational data models commercially, they easily able to understand the concepts as well as implement the concept comparing with other record based models. So that's why these relational model become more popular. We'll move to the next query. Next question. Describe the process of converting ER model into relational schema. We have done 2 lectures on this. One lecture we considered the entities, how the entity sets and attributes are converted, and one more lecture we discussed about how the relationships are converted into relational model. So that's why in any of the ER model, various entity sets will be there, strong entity set and weak entity set, and attributes will be there, relationships. These are the building blocks. While converting into relational model, entity set, for each entity set, one table must be created, one relation must be created, right? As well as attributes all attributes are related to entity sets are attached as it is, except the multiple attributes. If any multi-valued attributes are there, for them a new entity set is going to be generated. Similarly, relationships, one-to-one, one-to-many relationships are converted by just attaching primary key of one entity set to the other entity set, that is referencing relationship. Primary key, foreign key relationship can be considered, and many-to-many relationship can be converted by introducing a new table. These are all the rules discussed in the lectures of our database management series lectures. So that can be, just go through that so that you will understand in more effective manner. Okay, the next question is, discuss the disadvantages of file processing system and explain how these disadvantages are avoided. These are also discussed in first two lectures of database management series lectures. Please go through that. But in brief, these are the parameters we considered: data redundancy, inconsistency, difficulty in accessing data, data isolation, integrity problems, atomicity of the updates, as well as security problems. All these problems are more in case of file management system, file processing system comparing with the database management system. And all of them are going to be avoided. Specifically, redundancy can be reduced, not avoidable, but reduced maximum in our database management system. The last question in the part C is, design a relational database for university register office. Maintain data about the each class. So that's why each class we have to maintain a data, including instructor. So instructor must be an entity set. I'll just round off. And the number of students enrolled. And we have to need to store the data related to student also. So students. So enrolled for a particular course, and time and place of the class meetings. For each student, class, pair, a grade is recorded. So what are the entity sets we are going to have? Student, course, instructor. These are the entity sets. And others are relationships are connecting to these entity sets. Student enrolls for course. So that's why this is a relationship which is having a many-to-many relationships are there. So that's why a new entity set was created, a new table was created for that. And course offering. Every semester in a particular room and in a particular every year, a course is going to be offered to a section for a semester. So course offering is a relationship among the course and the type. And teachers is a relationship among the course as well as course offering and instructor. Requires main course. That means for course, a course is needed. Prerequisite, we will call it as a require. That means requires is a unary relationship from course to course only. So these are the relational database for a university registrar's office having this small scenario. For this scenario, this is the relational database design, that is underlined are primary keys actually. So like this, these questions in analytical thinking can be considered. Coming to the part B, most of the questions are theoretical questions which we discussed already. Compare and contrast file management system and database systems completed. Definition of abstraction, levels of abstraction was defined. Discuss about different types of the data model. Even in the definitions and terminology also I discussed about the data models. Various types of data models, object database models, record based data models, and physical models. We discussed various types of data models. Discuss additional features of ER model. We discussed the additional features of ER model, a separate lecture which consists of about weak entity set, strong entity set, and ternary relationships, aggregation, and generalization, specialization. These are the extended ER model, we will call it as additional features of the ER model were discussed. Explain in detail different types of the data independence. I explained in the class of basic database management system, basic concepts, as well as in terms and terminology also. What is data independence? Different types of the data independence, physical data independence, as well as the logical data independence were explained. Different types of database users also explained, even in terms and terms and definitions, terminology, as well as in the lecture also. List out different types of integrity constraints. We have done it is special lectures on integrity constraints, that is physical database integrity constraints related to the database design were done in 2 lectures. Domain integrity constraint, key integrity constraints, uniqueness, primary key, etc. under key integrity constraints, triggers, assertions, referential integrity constraints. All these things, 6 integrity constraints were discussed in 2 lectures. Please go through the lectures to answer this theory question. List out different types of integrity constraint and discuss about different keys used in database design. This was also explained in detail, 2 places, 2 lectures in ER modeling, before ER modeling, as well as relational model also. As a part of the integrity constraints also, various keys were explained. And I explained already strong entity and weak entity differentiation. Similarly, relation schema and relation instance differentiation was also explained. Even terminology definitions, terms and terminology definitions are lectures also, respective things are available in detail. List and explain the design issues of entity relationship were already explained. And construct ER diagram for a hospital with a set of patient and set of medical doctors associated with each patient, a log, that I'll explain. 14th question. A small ER diagram has to be drawn. I'll explain how to draw that one now. And just other things are all theory questions. For example, describe about basic concepts of ER model, that is about entity, relationship, attributes. 2 lectures were given on this topic. Discuss about ER model and relationship. This is also from those 2 lectures. Discuss about generalization with need diagram was explained in extended ER model lecture. Explain specialization. This is also under extended ER model lecture. It is there with this need diagram was explained to you. Describe about aggregation. This is also under extended ER model. So all theory questions were explained in the previous lectures. Lecture 1 to 47, you can just go through that. Basically, some terms and their definitions are there. Those can be, just revised in lectures, 3 lectures, 58 to 59, 57, as a definitions and terminology, under definitions and terminology area. So I'll come back to the 14th one. So this is the question, 14th question, a problem. A small diagram has to be drawn by us as ER diagram. What are the entity sets? Doctors are entity sets, patients are also entity sets, and a test will be there. Because a log of various tests to be there, various test information has to be maintained, means test must be an entity set actually. So 3 entity sets are there, patients, doctors, and a test. So patients undergo some test, no? So the test log will be there. So test log is connected with the test, which patient, which test was organized, what are the results. And doctors are going to be examine patients. So doctor-patient relationship we have written here, and you can write examine. Doctors examine, any relationship name can be given. And doctors perform this test for various, suggest or perform various tests with respective attributes. You observe test is having test ID, test name, and date and time. They are specified a log of various tests. So it will maintain the list of log of means list of tests conducted for a particular patient. So multiple tests to the single patient. So many to one relationship. Doctor's patient is a many relationship, because a doctor can treat multiple patient. A patient can may be treated by multiple doctors also. And doctors suggest or perform a single test may be performed by multiple doctors also. It depends upon the test, no? So that's why. So these are many relationship. This is also many relationship, but this is many to one relationship. Here this log test is having a unary relationship also. Okay, this is the solution for our entire our ER diagram of a hospital environment. Okay, so this is the part B. And coming to the part A is all our definitions, small answers which are all available in the previous lecture. Easily you can understand and answer these questions. Each question is having a Bloom's taxonomy level. Part 1 is going to be having remember and understand. Part 2 will be having, that means part B is going to be having remember and understand. Some of them may be apply. But part C is apply and analyze only. So if you observe that part C is going to be having apply and analyze, which are having some application of the concepts which learned during this module actually. Thanks for watching. Hope the solutions are useful.
Like, share and subscribe. Hit the bell icon for more updates.